Hello everyone. In this second lesson on applications, we're going to follow the same outline that we did in the first note with with the same four steps. But we're going to look at a couple different word problems and how we can apply that approach to these questions here. So in the first example, we have a store that's trying to make a mixture of peanuts and almonds. So peanuts will cost $4 for every kilogram, where almonds cost $10 for every kilogram. The store is trying to make a 10 kilogram mixture of these two together, and they're aiming for the price to be $5.80 per kilogram. So notice that as we mix the peanuts and the almonds together, the final price of this mixture is going to fall someplace in between them. The question then is how much of each of these two nuts do we need to mix together so that we can get the exact right quantity, 10 kilograms, and the exact right price per kilogram, which is $5.80 per kilogram. So again, if you remember the steps that we took with our word problems in our last lesson, the first thing is our let statements. And again, we pointed to this last sentence typically where they're going to ask us what they want us to find, and that's how we can set up our let statements. So they're saying how much of each of them are needed. Okay, talking about the peanuts and the almonds. So how much of them? So that's where we will start then. We'll say let X represent the mass of peanuts. If we're saying how much, okay, we're talking about then the mass of each of them. So let X represent the mass of peanuts, and we'll say then let Y represent the mass of almonds. Now, trying to set up our equation. Again, I'm sorting through what information is given. So we know the cost per kilogram for each of them. We also know here that the store is trying to make a 10 kilogram mixture. So if X and Y is representing the mass of each of them, my first equation I'm going to come up with here then is just what is that total mass. So if we look at the mass, I know that the mass of peanuts plus the mass of almonds has to give us a total mass of 10 kilograms. So there's our equation 1. The second thing that they do is they give us a whole bunch of costs here. The cost per kilogram here, the cost per kilogram here, and then the cost per kilogram of that final mixture. So now we're going to actually use that to come up with a second equation that is based on the cost. So what is the cost of peanuts? Well, it's $4 for every kilogram, and we have X kilograms that we're going to use of peanuts. Again, if I put a number here for a second, if I had 3 kilograms of peanuts, then we would do 4 times 3. If I had 4 kilograms of peanuts, I'd do 4 times 4. If I did 5 kilograms of peanuts, I would do $4 times 5 to get the total price. What we have is X kilograms, so in a similar way, we're going to do $4 times X kilograms. That will tell me the cost of the peanuts. In a similar way, then we're going to add on, it's $10 for every kilogram of almonds. So we're going to do $10 times whatever the mass of almonds is. This will give me then the cost of all the peanuts. This will give me the cost of all the almonds. And now we need what is the total cost. Well, our total cost is $5.80 per kilogram, but remember we're doing 10 kilograms of this, so I need to multiply that by 10. So there's the total cost of peanuts plus the total cost of almonds, and then here is the total cost, $5.80 per kilogram times 10 kilograms. I'm just going to put an equal sign here beside this if I work this out, and we figure out that that total mixture will be $58. And there then is our setup, our two equations. This is really the word problem part here. Okay, the word problem part is figuring out what our variables need to be, which we can often get from the very last sentence in the word problem, and then trying to sort through the information that is given to come up with two equations. Once we have that, we're back to what we have spent the most of this unit doing, which is how do I now solve this? Notice that we don't have any decimals. This here we got rid of when we multiplied this out here. So now it's up to you. Do you want to use substitution? We could isolate for one of those two variables if we wanted to. My preference, I think I'm going to use elimination, and I think I'm going to make my y's match up. So I'm going to say I'm going to take equation 1 and multiply that by 10. So these would be the same. If I do that, I need to multiply each term. So 10x plus 10y equals 100. Again, as we change an equation, we renumber it. So now I can refer to that as equation 3. Equation 2, again, we just want to keep everything lined up and stacked up. So I'm just going to repeat that equation. This one I am not changing because I was able to make the y's the same. And then I will just write the number here that we're keeping that as equation 2. Now that our y's match up, okay, to eliminate here, I'm going to have to subtract them. So I'm going to indicate that on the side. We'll do equation 3 minus equation 2. That'll give us then 6x equals 42. Dividing out to 6 tells us that x is 7. Okay. There's the first half of our point of intersection. Okay, we now have the mass of peanuts, like we've seen in many of our other questions. Our second step then is I will take that answer, 7, and I will sub that back into. Okay, again, we have our pick, equation 1, equation 2, or equation 3. In this case, I think equation 1 is going to be the easiest one to use. So we have 7 plus y is 10, or we can quickly see here that y is 3. Our last step, fourth step, then is our conclusion. Therefore, and again, please make sure as you conclude this that we're not concluding a point of intersection anymore, but we are now using that point of intersection to give us an answer to this problem. How much of each of them were needed? Okay, X was the mass of peanuts, so therefore they need 7 kilograms of peanuts and 3 kilograms of almonds. One thing I want to point out is in our conclusion, just be careful that we have our units that we are talking about. Okay, and there is again, similar to our last lesson, our 4 steps, our let statements, our equation, our solving, and then our conclusion to that problem. The last word problem that I want to take a look at here with you is if we deal with an interest type question. So I've just set up 2 statements here quickly just so we can review what does it mean to calculate interest. So if you either borrow or you invest money, so for example, if you were to borrow or invest $500 and you're borrowing that at 6% per year, okay, this is telling you how much interest they are going to calculate on this here. If we invest money, we can think of interest as the free money that the bank or the investment will pay us for leaving that money with them. If we think of it from a borrowing perspective, then this would be the extra money that we have to pay at the end of a year to borrow $500. So how much extra would we get at the end if we invest it, or how much extra would I have to pay if I borrow that money? So we're saying that we are calculating 6% interest. So what I would need to know then is what is 6% of that $500? And we can translate that to mathematics by converting our percentage to a decimal. Remember, percent means to divide by 100, or we shift that decimal place 2 places. So as a decimal, 6%, 0.06. The word of in math often gets translated to multiplication. So 6% times 500. And if we carry that out, we figured out that the interest is $30. In other words, if I invest $500 for 1 year, they're going to pay me an additional 6% of that. In other words, they're going to pay me an additional $30. At the end of the year, they would give me back my $500 plus an additional $30. If you think of it from a borrowing standpoint, if I had to go to the bank and borrow $500, at the end of the year, I would have to pay them back that $500, but I would also have to pay them an additional $30, and that's how interest works. So we'd have to pay them back $530 to borrow that money for 1 year. Now, in our questions, we're typically not going to know how much we need to borrow or invest. That's what we're actually going to be calculating. So ours will look more like this here, where it's going to say if you were to borrow or invest X dollars, because we don't know what that is, at 8% each year, then the interest is. Well, the calculation works the same as this here. I would need to know what is 8% of that X dollars, whatever that is, or algebraically then we could write this as 0.08 as I convert the percentage to a decimal, and 0.08 times the amount of money that we have invested or borrowed. In this case, that is x. I can't complete the calculation, but I can create now this algebraic term, the same way that we had the expression here that we could calculate. So that's the idea. Now, if we put that into a bigger question, here's what this would look like. So Kevin is invested $8,500, but he's splitting that up into two parts. So this is why we don't know how much he's investing here. He's going to put part of it at 7%, and he's going to put the rest of it at 12%. At the end of 1 year, he earns, so this is his interest, he's now earned $720 in interest. So he knows how much he has at the end, like this here. The problem is that it's not a single investment. He's taken this money and he's split it into two chunks, and we don't know how he has split that money up. That's what we're going to find. How much did he invest then at each of those two rates? Again, like our other word problems, if we start with our let statements, focus on the end of the question. I know there's a lot of numbers and a lot going on here, but if we break this into pieces, then we can just focus here just on this last part. It says, how much did he invest at each rate? So there are then our let statements. Let x represent the amount at 7%. How much do you invest at 7%? And let y represent the amount at 12%. So there's those two amounts. Now, what do we know? We know that in total, he invested $8,500. So the first equation that we can do is just a total. We have these two parts, x and y, and we know that that has to total $8,500. There's a total that he invested. So there's our first equation. The second equation now comes from our interest. So the same way we looked at how to calculate interest here, we're going to do the same thing. What we know is that the total amount of interest has to be $720. So I need to figure out how much interest did he earn on the first part and how much interest did he earn on the second part, and that will have to equal or total $720. So the same way we did this calculation here, I'm going to do the exact same thing here. He invested X dollars, we don't know how much that is, at 7%. Okay, here 8%, here 7%. So the same idea that we used here, I'm going to say the interest is 7% or 0.07 times x. There's the interest from that first investment. To that, we're now going to add on, what's the interest from the second investment? Well, the second investment was at 12%. So as a decimal, 0.12 times y. There's our interest from the first investment, there's our interest from the second investment, and what I know is that that has to total up to $720. So there is our second equation. There's really the new part here today as we set up this interest question. Now, completing the question, we'll go through all the solving here as well, but this is the new step here that we're looking at. So as we solve this, first thing that I'm looking at is that I have an equation that has decimals. Again, I like to keep the two equations stacked. So initially what I'm going to do is say, let's just keep equation 1 alone. So we'll leave that alone. There it is. Okay, that is still our equation 1. However, my equation 2, I want to shift that decimal place here 2 places for these two terms. So I'm going to multiply everything by 100. If I do that, that's going to give me 7x plus 12y equals, don't forget, this is often a spot I see students miss this because this one doesn't have a decimal, they leave this alone. But if I'm multiplying by 100, I have to multiply all three terms by 100. So if I multiply that by 100, okay, that's going to now make this 72,000. Again, as I change an equation, I do renumber that. I now got rid of the decimals, so now I'm trying to solve. And again, we have two options. I could isolate for either the x or the y here, or again, as you've seen in many of my examples, my preference is I'm going to use elimination. So what I'm going to focus on is the y's. I'm going to make them the same. If you wanted, you could make the x's the same. That's your choice. I'm going to multiply equation 1 by 12 to make these here match up. So as I do this, I'm going to get 12x plus 12y equals, you're going to have to use your calculator. Okay, I've already gone ahead and done that. So we end up with 102,000 for that. Again, as I've changed this equation, I'm going to renumber it and say there's my equation 4. My second equation here, so equation 3, I'm not touching, so I'm just going to put an arrow and say here is that second equation, 7x plus 12y equals 72,000. And that's equation 3, we didn't change it. Again, as we focus on this part here, there's where the terms are the same. So I am going to subtract these two equations. 12 minus 7 will give us 5x. 12y minus 12y, they will subtract out. And if I subtract here, we end up with 30,000. Divide out the 5 tells us then that x is equal to $6,000. In other words, we just figured out here is the first half of the investment, $6,000. Once we have the first half, I take that answer and I'm going to sub that back in. So we will say sub x equals 6,000 into, as we've seen before, we have the option equation 1, 2, 3, or 4. Again, the easiest one here is I think that equation 1. So if we sub that in, we have 6,000 plus y is equal to 8,500, or y is equal to 2,500. Our last step, therefore, he invested, okay, x was $6,000, so he invested $6,000. Go back to our let statements if we need to double check. X was at 7%, so he invested $6,000 at 7%, and $2,500 at, and then double checking, at 12%. Okay, so there's our two new styles of questions for today. Okay, mixing things where we have sort of this unit cost idea, and that can go to a bunch of different examples. You might be mixing candy or a number of different things in this way where we have a unit cost. Okay, and our second one dealing with interest rates, either borrowing or investing money, where we have two amounts that we're either borrowing or investing, and we're trying to figure out how much is falling into each category. Take a look at the practice questions, okay, and if you have any difficulties, let me know. Have a good day, everyone.